Windar Photonics first saw the light of day in 2008 as a spin-off company from the Danish technical university Risør research environment, where the basic blueprint for the cost-efficient LiDAR technology was initially conceived in 2005. In 2014, Windar Photonics was established as a PLC in the UK and listed on the Stock Exchange of London AIM in 2015. Currently, Windar Photonics has done more than 130 installations of the Windar Photonics LiDAR optimization solution around the globe and established both sales and technical representation in the EU, the US and China. The LiDAR emits two laser beams horizontally at a range of 80 meters in an angle of 60 degrees. The light emitted by the sensors measures the movement of tiny particles in the air and transmits the measured data to the wind turbine controller every second. Measurements validated by the Danish Technical University, DTU, has shown a precise degree of correlation between the measurements of the LiDAR and the measurements of a meteorological mast regarding both wind speed and wind direction. The Windar Photonics LiDARs optimize the wind turbine by correcting yaw misalignment, which increases the AEP by 1.5% to 2% on average, and in some cases even by as much as 4%. Furthermore, the Windar Photonics LiDARs will alleviate damaging loads on the turbine, enhancing the lifespan and uptime of the wind turbine. Most turbines have some degree of yaw misalignment, which results in the turbine being subject to potentially damaging loads and a suboptimal energy production. The LiDAR precisely aligns the wind turbine to the oncoming wind, significantly reducing the loads associated with yaw misalignment on the turbine. Wake situations can be caused by several conditions relating to the wind turbine's environment. Wake is often caused by the distortion of the wind flow from nearby wind turbines, essentially increasing the loads on the affected turbines. The LiDAR can detect wake by tracking the changes in the signal shape between the LiDAR's beams over time. The data collected by the LiDAR can be applied to adjust or regulate the relevant wind turbines to circumvent the wake situation. Wind shear occurs when the wind speeds vary significantly at different altitudes, causing the wind turbine rotor to be subject to vastly different oncoming wind speeds, which will cause even more strain on the turbine in general and specifically on the rotor and the gearbox. Due to the wind vision's ability to measure the wind speed at various altitudes, the LiDAR is able to detect wind shear, which can subsequently be alleviated through the turbine's controller. Gusts are essentially substantial variations in wind speed within a short time frame, where the wind speed suddenly increases before reaching the turbine and causing the power production to spike above the rated level. The LiDAR's gust detection can potentially anticipate gusts, allowing the turbine to pitch preventively, hence averting the increased loads and power spike. Utilizing complex algorithms, the LiDAR is able to detect turbulence and store the data for later analysis. The data can provide a basis for further load optimization of the turbine by the wind turbine owner. The Windar Photonics product portfolio currently includes 4 different LiDAR solutions that have their individual strengths and advantages, depending on whether the LiDAR needs to be installed as part of the design process or as a retrofit solution. The Wind Vision is a complete optimization strategy for yawing, pitching and detection of load-increasing phenomena. The Wind Vision LiDAR is intended for direct integration with the wind turbine controller. The 4 beams allow the LiDAR to measure in both horizontal and vertical planes, which enables the wind vision system to detect wind shear. The Windar LiDAR ensures a continuously well-aligned wind turbine, which is subject to fewer damaging loads, through dynamic yaw misalignment correction by measuring the wind in front of the turbine. Additionally, the Windar can detect gusts, wake and turbulence. The Windar can be directly integrated with the wind turbine controller as part of the design stage. The Windtimizer is a mediator that allows the Windar to be integrated with the wind turbine controller in cases where direct integration is not an option. Utilizing the Windtimizer enables the LiDAR to perform dynamic yaw optimization. The retrofit control system is an optimization solution intended for older assets that can benefit from the combination of a new control system and a LiDAR sensor. Additionally, the retrofit control system allows the wind turbine to perform anticipatory pitching in relation to gusts. Because of the compact and lightweight design, the installation of the LiDAR can be done in less than 6 hours and requires no special hoisting solutions or cranes. The system contains no mechanical moving components, and all vital parts, even the light source itself, are installed inside the nacelle. As a consequence of this, the parts outside the nacelle require almost no maintenance. The system keeps a high degree of data availability in all climates, even during heavy rainfall. The LiDAR is IP66 protected, and the special coating and anodized aluminium construction will let it survive all possible weather conditions. The lightning bracket, specifically designed for the LiDAR, guarantees that the LiDAR is properly protected against lightning in the lightning zone 0B. The specially developed vibration system ensures that the LiDAR can operate in a vibration range of 1 to 500 Hz. The LiDAR has been developed to be operational in even the coldest environments and will function in temperatures as low as -40 degrees Celsius. The special heating elements will prevent ice from being formed on both the windows and on the outside of the unit. The Windar Photonics LiDARs have been installed on more than 100 wind turbines and will benefit most turbine models in any climate. The Windar Photonics LiDAR optimization solution is very cost-efficient and will help reduce loads on the vital parts of the wind turbine, hence increasing the lifespan and the uptime of the wind turbine. Furthermore, the LiDAR will yield increases to AEP by as much as 1 to 4%, providing a fast return on investment for the wind turbine owner.